Hello everyone, myself Preet Padaria. Today I will discuss threading in Python. So for that, let first see part one of that. So question arises: what is thread, right? So for that, all programmers are familiar with writing a procedural program, which refers to sequential execution of a program. A program can be described as the set of statements which we don't need to dig up that in deep. A normal program which you have written till now, mostly they all have one start, one endpoint, an execution sequence. Unless you don't have knowledge of threads. Okay, so we will discuss that, what will be in thread. This simply means that your program has single life, single point of execution at given time during execution. A single thread is similar to sequential program described as earlier. A single thread is also having single point of execution and one start point and one end point. It is started that at any given time during runtime of a thread. There exists only a single point of execution which is always true. Right? So now let's see the definition of thread. A thread is a single sequential flow of control within a program. So the flow of a thread in a single sequential flow. A thread is separate flow of execution. The real excitement surrounding thread is not about a single sequential thread. Rather, it's about the use of multi-threading running at same time and performance during tasks in a single program. This is illustrated in next figure. As a program is known as a thread, but there is a multi-threading are also there. So let's see this. So from diagram you can see this is single flow of a program, which is also as a thread, and we have taken references of those diagrams, and also this is multi example of multi-threading, which is two thread running concurrently. For instance, a web browser is an example of multi-threaded application. Within a typical browser, you can scroll a page while it's downloading an applet or an image, play animation and sound concurrently, print a page in background while you download a new page, or watch three sorting algorithms race to the finish. So you can see we can using multi-threading in our day-to-day life regularly. Also, any kind of game is an example is also an example of multi-threading application, because playing sound, showing graphics, etc. different kind of work are being managed by multi-threads in one program to make games even smoother or player to play and enjoy. So now let's see a state of thread is a term which determines the fate of thread. A particular state of thread will decide that how this thread will proceed further. At any given point of time, a thread can exist in following state. So there are few states of thread. So first, new, runnable, blocked, waiting, timed waiting, and terminated. So let's see the process. So here from if thread starts, here new, here only thread created, then it will start an runnable state. After that, those are the stages which will be explained in few minutes. Life cycle of thread. Now see new thread. When a thread is created, it is in new state. The thread has not yet started to run when the thread is in this stage. When a thread lies in new state, its code is yet to be run and hasn't started to execute it. In runnable state, a thread that is ready to run is moved to runnable state. In this state, a thread might actually be running or might be ready to run at any instance of time. It is responsibility of thread scheduler to give the thread time to run. A multi-threaded program allocates a fixed amount of time to each individual thread. Each and every thread runs for a short while, and which pauses and relinquishes the CPU to another thread so that other thread can get a chance to run. When this happens, all such threads that are ready to run, waiting for the CPU and currently running the thread lies in a runnable state. Now let's see blocked or waiting state. When a thread is temporarily inactive, then it's in one of the following state: blocked or waiting. Let's see in figure. So both are quite similar. Equals a lock and lock acquired, and in waiting state, waiting for notification, also waiting for acquired. So now let's discuss about time waiting. A thread lies in time waiting state when it's called a method with a time output parameter. A thread lies in this state until the timeout is completed or until a notification is received. For example, when a thread calls sleep or a conditional wait, it moved to a time waiting state. Last state as terminated state. A thread terminates because of either of the following reasons: because it exists normally. This happens when the code of the thread has been entirely executed by the program, or because there occurred some unusual erroneous event like segmentation fault or unhandled expectation. Now, multitasking leading through multi-threading will be explained by my friend Henil.
So hello everyone, my name is Hanil Mistry, and as you might have been guided by Preet Padaria, that the basic terminologies and the information about thread, a single thread. So now you might be comfortable to understand these terminologies, multitasking, multi-threading, and all that stuff. So let us just start discussion. Understand the multitasking and multi-threading. So they are quite similar, but there is a quite little difference between them. So first of all, multitasking. Multitasking, as you can see on the definition on the screen, is the concurrent performance progress of several tasks, which leads to performance of multiple tasks at a time. So basically, the whole funda about multi-threading comes from the multitasking. So as we have discussed earlier, that the beauty of thread is lying in multiple thread at the same time. So you might have seen this graph. You can see this figure. You might have been seen in first part that have been guided or told by Preet Padaria. So now let us just continue. That as we have discussed earlier, so since we are talking about execution of multiple tasks simultaneously, we might face some of the difficulties while doing or trying to achieve multi-threading environment. So multi-threading environment is very difficult to achieve, and there may be some conflicts or problems. So we will discuss about that what are the problems first, and then we will then we will jump on the coding section. So first and foremost, we need to make sure that concurrency must be achieved, and somehow we need to maintain the context switching. So these two is very important, that concurrency and maintain context switching. So as there are simultaneously running threads are there, we need to maintain concurrency and context switching between the among, or you can say among all the threads that are running simultaneously in one program. So writing and debugging code which is made to achieve multi-threading is difficult. So this is also a second problem, that debugging the code and writing the code in multi-threaded application is very difficult. And in addition to that, you can see this figure. We have taken the reference that issue while dealing with the multi-threaded programming. So these are the issues: increased complexity, compilations due to concurrency, difficult to identify errors, testing complications, unpredicted results, and complications for porting existing code. So these are some issues that you might deal while creating any multi-threaded application. So beware about all. However, we can deal with those issues. First of all, accept those issues and trust, and let us first understand the type of multi-threading. So these are the issues that you keep in mind, that you need to keep in mind. So now we will discuss about multi-threaded environment. The basic overview has already been given to you as I have discussed in this section. So now we will jump on the types of the multi-threaded environment. So there are two types of multi-threaded environments. The first is process-based multi-threading, and the second one is thread-based multi-threading. So what is the difference between them? In short, I might tell you that process-based multi-threading is related to OS, while the thread-based multi-threading is related to program. So let us just discuss in the deep. Execution of several tasks simultaneously, where each task is having separate independent program, is called process-based multi-threading. For example, while typing a program in any editor, we can listen to audio songs from the same system. Yet same time we can also download a file from internet. So all these tasks will be executed simultaneously and independent of each other. Hence it is process-based multi-threading. Process-based multi-threading is the best suitable at OS level, as I have said you. So now we will discuss about thread-based multi-threading, and our whole article is based on this topic, thread-based multi-threading, and specifically in Python. So executing several tasks simultaneously, while each task is separate independent part of the same program, is called thread-based multi-threading. So you can directly see the difference, that executing several tasks simultaneously where each task is having separate independent flow, and what is happening over here, executing several tasks simultaneously where each task is separate independent part of the same program. Here the programs are the different, and here the program is same. So this is called thread-based multi-threading. It is best suitable at programming level, as I have said you, whether it is process-based or thread-based multi-threading. The main objective of multi-threading is to reduce response time of a system and to improve performance. So the main important application area of the multi-threading are that we have listed over here: multimedia graphics, animations, video games, web servers and application, etc. In this whole section, we have briefed you about thread. Now you will be able to differentiate between threading, multi-threading, multitasking, etc. So here are some useful terms to remember from this article: thread, life cycle of a thread, thread states, multitasking, multi-threading, process-based multi-threading, thread-based multi-threading. So these are the some terms that you might see while going through this article. So what is the conclusion of this part? So in this article, we have learned the basic of thread, that what is the basic definition and state of a thread, the states and life cycle of a thread. We have also learned that what is multitasking and multi-threading, and in addition to that, why we need multitasking or multi-threading, that we have also learned. What are the types of problems, or what are the problems while we want to achieve multi-threading, that is also we have discussed. What are the types of multi-threading and all the stuff, that is also we have discussed. And now you will be able to understand the upcoming programming based implementation of threading, and specifically we are going to brief you about the coding in Python code. So this was the conclusion, or you can say the explanation of the part 1. Now we will start the basics of programming. So you can see the getting started with thread in Python. So part 2. In this part 2, I will brief you that how we can create a basic thread in Python, and upcoming the extraordinary multi-threading will be explained by my fellow partner Harshil Parsara. So let us quickly go through the introduction. As we have discussed in part 1, that what is thread and why we need thread. As you might be aware that threading is a term which usually needed to achieve multitasking. In this part 2, we will be giving you some glimpse of threading implementation in Python with the basic thread terminologies that we have covered in part 1. It will help you to understand better in this part. So let us just first look at threading module in Python. So this is basically threading module in Python, which was included in Python 2.4, which has provided more powerful and high-level support for threads than the previous ones. In addition to some advanced method, this threading module consists thread class and implementation of threading and methods, which are provided by the thread class and which are mentioned below. You can see the methods run, join, start, get name, set name, and is alive. Creating a thread in Python. So let's look at that how we can actually create a thread in Python. There are basically two ways to do so. So first thing, by inheriting the thread class. So here we are going to we imported the thread class from threading module. So first I will going to open the code. This is a GitHub code. So as you can see, importing the thread class. So importing the module threading, and from threading we are importing the thread. So this is the code for creating a class to thread. So we have created a class test, and we have defined the run method. This method I will explain you later that what the run method do. And we have created two objects of this class, t1 and t2, and we are invoking the start method. This method I will also going to explain. So this is the basically code. Now first let us understand about the basic methods. So here we have imported thread class from threading module. After that, in test class we have inherited the test class, as you can see on this code, and thread class and overridden the run method. In run method we are calling get name method, which returns the name of the current thread which is executing. After defining class, we created two objects, as you can see, t1 and t2. Now if we want to start a thread, then we have to call start method. If we directly call the run method, then it will not create a thread. After invoking start method in this program, we have total three threads. One is main thread, second is t1 object and t1 objects thread, and last is t2 objects thread. So the output of this code, as you can see on the screen, and what is main thread and what are the different method, and the explanation of multi-threading will be now explained by my fellow member Harshil Parsana. Thank you for listening to me.
Hello everyone. So my name is Harshul Parsala and I am going to explain what is main thread and how to create a thread by thread class object, and what is the different methods of thread class that I am going to explain in this video. So let's start. So first, what is main thread? So in normal condition, the main thread is the thread from which the Python interpreter was started. It is a basic and compulsory unit of execution for any program, because without thread there is no existence of process. You can also consider that it is a by default thread which will run without any invocation for execution of any Python file. So this means that any programming language you are writing, in that the main thread is compulsory. Without main thread your program is not executed. So main thread is compulsory for every language, and it is by default. When you run your program, the main thread is created automatically. So next is, you can also consider as abstract thread from which any number of child threads can be spawned, as we are doing. So from main thread you can create any number of threads, child threads. So how to create a thread, let's see. So by using thread class object. So if we don't want to create our own class, then we can directly create thread class object and use it. Means if we can create a thread, by using thread class object, and we do not have to create our own class. So how can we do that? So for that, at the time of creating object of thread class, we can give name of thread and also target method name, which will be called when we start the thread. If you don't want to give name and other parameters, then it also fine. So here we have defined two methods. So this is the code. This all means this all theory is related to this code. So I am going to explain this code. So here we created two methods, method 1 and method 2. From method 1 thread name threading dot, this is a threading module in which that thread class is exist. So from threading module, current thread dot get name. This current thread means the thread which is executing, and from current thread dot get name means this get name function returns the name of that thread. Similarly as method 2. So we have created t1 is equal to thread. This is the thread class object, and name is equal to thread means the thread which is created by this t1 object, that name is thread1, and target method is method 1. And similarly as t2, and for t3 we have only created thread method. So after that we have called start method. If you directly call that method 1, that is not create thread. Because of we called start method, that is created a thread. So if we see the output of this code, then it is look like this. From method 1 and from method 1 thread name thread 1, from method 2 thread name, the name of thread is thread 2, and the for t3 object there is no method, so the output of t3 thread no output. So you might be wondering that what are these methods which is used in such as start, run, etc. So for that, let's take a look at those such methods. So useful methods in thread class. There are several kinds of methods are there in thread class. Let's talk about each method which are there exist in thread class. So first is run method. The run method is inbuilt empty method of thread class. The run method defines the body of the thread. The run method gets its code the following two ways. First, when the run method is overridden in a subclass, as we have done in first example. So my friend explain Hanil Mistry how we can override the run method. So next is second is using thread class constructor. If we which is we see in a few minutes ago, when thread class object created a callable object is passed as a target through the constructor, as we have done in the last example. So what is start method? Then start method is inbuilt method of thread class which is used to start a thread. The start method calls run method indirectly. If you do not call start method and directly call run method, then it is not created a thread. So if you want to create the thread, then you have to must call start method. This method must be called at the most one time for one thread. If it called more than once, it will give runtime error. This means if we call t1.start, after that you can't call t1 object again. And if you call the t1 object t1 thread again, start again, then it will give runtime error. So the return type of start method is none. Join method. So what is join method? When join method is invoked, the calling thread is blocked till the thread object on which it was called is terminated. Means if you call join method over t1 object, then it is waiting for the thread which is executed. After that, the t1 is executed. So for example, if join method is called from a main thread, the main thread waits till the child thread on which join invoked exists. The use of join method is if join method is not invoked, then the main thread may exit before the child thread, which will result undetermined behavior of programs and after program invariants and integrity of the data on which the program operates. So now we will see the example of multi-threading. So for example, we are going to see this code. So first is from threading module we have imported thread class and imported random class. So this is the list for random numbers generating. First we have generated 15 random numbers in a list. Now we have created two functions, print odd. Basically this function makes a list of odd numbers from these random numbers, and this function makes even numbers list from this random numbers list. And we have created two threads, odd thread and even thread. So in odd thread we passed print odd function as a target, and even thread we passed the print even function as a target, and name of this thread is odd and name of this thread is even. So we have called start method of both the thread. So output of this code is like this. So first we have print the random number list. So this is the random number list, and this is odd numbers, and this is odd numbers list which is printed by odd thread, and this is even numbers thread which is print by even thread. So this is the example of this Python multi-threading example. So next is Python multi-threading applications. Most of the application you see in daily life have multiple threads running behind the scenes. Consider your internet browser like this. I am using this Chrome browser. So it is the best example of multi-threading programming. Why? Because at any time you may have number of tabs open, each one displaying various types of websites, video blogs. So this means that I am opening these three tabs. So these three tabs are three types of thread. If you are open WhatsApp, YouTube, so this is different thread. So this is four threads which we are using so this is also a multi-threading, best example of multi-threading, multi-threading. So another best example is Microsoft Word, because in Microsoft Word you are typing and the Microsoft Word is checking your spell in backend. So which is also best example of multi-threading. In games, the graphics means you are fighting with someone else, and someone else is also fighting with you. So that is also multi-threading example. So references of this part is this is the reference for what is thread in operating system, and intro of threading in Python, and this is our GitHub repositories. And this whole blog is prepared by Hanil Mistry, Harshal Padsala, and Preet Padaria. So thank you everyone for listening us, and I hope you enjoyed this blog. So thank you everyone.